Check the torque settings on panel 47-alpha. Copy that. Logging the entry now.
Verify main strut actuator alignment, tolerance within 0.005. Confirmed. All systems green. Proceed to avionics check. All green across the board for the landing gear inspection. Excellent. Make sure the torque wrench settings are logged.
All pre-flight checks are satisfactory. We are clear for fueling.
Affirmative. Commencing starboard inspection.
An observer may wonder why in such a complex and high-risk field like civil aviation, success is treated as something almost obvious.
No one in the hangar speaks about the possibility of failure, yet every action is performed as if preventing it every second. The disciplined silence fills the space and makes the question clearer than ever.
Is success truly assumed, or is it merely a surface covering an extremely strict control system behind it?
Okay, section 3, line by line. Fluid levels checked.
Confirmed.
Pressure gauge calibrated.
Verified.
The central question becomes clear: why in civil aircraft engineering, people behave as if success is guaranteed?
In normal operation, every process in the hangar is designed to repeat precisely as it did yesterday, and will tomorrow.
Inputs complete. Verification required for sequence 32.
Verified. All parameters within tolerance.
The middle-aged Caucasian female engineer does not trust natural perfection but always verifies every detail, even when the result already seems correct. Workers do not rely on personal experience, but follow strictly standardized procedures. The narrow-body aircraft standing in the hangar is not a symbol of completion, but a system awaiting confirmation down to the smallest detail.
Success in this environment does not come from luck, but from eliminating every uncertain factor.
Every process is double-checked, and every result has an independent validation system.
This creates a state where everything appears correct, because errors are eliminated before they can appear.
Yet this perfection leads to a deeper question.
If everything is always assumed successful, where has failure gone within this system? The female engineer does not ignore the small deviation, but treats it as a sign of a deeper issue.
Workers pause not because failure has occurred, but because it could occur.
A contradiction emerges where a system considered always successful behaves as if failure is constantly present. If success is assumed, why is every action focused on finding errors? If everything is designed to be correct, why are so many layers of inspection required?
The invisible tension reveals a different truth beneath the surface.
Success is not the starting point, but the result of a continuous battle against potential failure. The question sharpens whether success is assumed or simply the final result of a system that does not allow failure to exist. The answer lies in how the system is built from the beginning.
Civil aircraft engineering does not assume success by ignoring risk, but by ensuring all risks are controlled before flight.
The female engineer does not wait for failure, but eliminates its possibility from design.
Workers do not fix problems when they occur, but ensure they cannot occur.
The entire system is built on the principle that eliminating all failure possibilities leads to inevitable success. This creates a paradox where success is assumed not because it is simple, but because failure has been systematically removed. Discipline in every action is not to create success, but to ensure no failure passes through.
When no errors remain, the only possible result is success. That is how civil aviation turns uncertainty into near certainty.
The difference becomes clearer when compared to fields where errors are still tolerated.
Here, a near-correct result is never accepted, while elsewhere it might be considered sufficient.
Small deviations are never allowed here, while in other fields they may be ignored. Workers do not finish tasks on time if absolute standards are not met.
Civil aircraft are not designed to operate with tolerance, but to eliminate it.
This creates an environment where success is the result of elimination rather than effort. This shows that assuming success is not optimism, but the result of extreme control systems. There is no room for luck here, only certainty. And that certainty is built step by step, layer by layer, process by process. That is why success here has a completely different meaning.
Looking at the entire process, success is not the starting point, but the inevitable outcome of risk elimination.
Zoom in on sector Gamma 12. The thermal readings are spiking.
Confirmed. The laser scan shows significant stress on the bolted beam. We need to flag this immediately.
The aircraft does not fly safely by luck, but because all unsafe possibilities have been removed beforehand.
Assumed success is actually confidence, built on thousands of layers of verification.
Success is not hoped for, but guaranteed.
And that guarantee is what makes it appear as a default state.
But behind that default is an endless process of detecting and eliminating errors.
This is the core philosophy that makes civil aviation one of the safest systems in the world.
And that is why in civil aircraft engineering, success is always assumed, but never taken lightly.